Okay, here we go. So second part, which is basically I'm just talking about. I'll talk about the Simplon camera based system, and actually not Simplon based camera system. Other than that, just for the historical purpose, and few things that insights that we can get from this presentation. So I want to make it complete. That's why I didn't want to left these things. Okay, so let's move. So basically, in principle of projection, what we project to cornea, and then we'll get the curvature. So projection-based method, the image is formed on the surface of the tear film, isn't it? It's basically we say cornea, but basically it forms on the tear film. So it's the same way that slide project on the screen. So here's the object, maybe Meyer, maybe placido disc, maybe whatever. When it projects to the cornea, and there is an image. Basically, cornea or tear film acts as a convex mirror, isn't it? So it's simple as that. Okay, I have discussed about it in keratometry video. Just you can go and watch that. So basically, principle is reflection based. So analysis of reflected image is measured as a slope of the cornea whenever we project there. Okay, so that's it. So advantages and disadvantages of projection-based system are compared to reflection-based system, video characteristics. So basically, what is the projection-based and reflection-based? So basically, we just discuss what are the advantages of the disadvantage projection-based topography. Advantage is corneal height is measured, irregular surface is measured, definitely non-reflective surface measured, entire corneal area is measured, and high resolution resolution accuracy and uniform accuracy across the cornea and lack of spherical bias, because in case of reflection base, basically I just wanted to talk about keratometry. We think that cornea is we suppose that cornea is sphere, isn't it? So disadvantage is prototype less easy to use, image acquisition it takes long time, no standard presentation format, fluorescent installation in some case we use, some case that is used, but it's just like historical purpose, isn't it? So let's the main thing you have to understand is this influence of TRF film, and it will definitely account in like example in case of Simplon based camera, because in case of Simplon based camera, like there are a lot of uh, dual working mechanism that in bone cirrus there is definitely placido discs at the same time Simplon based camera, and two system work complementing each other, not exactly complementing, but yes, two systems are there. But hybrid system nowadays is very famous. So that's why you have to understand the reflection based and what is the influence of reflection based tear fluid in reflection based. Okay, both reflection and projection based topographic system image on the air tear fluid interaction rather than the surface on the corneal epithelium. So that's why no matter what, tear air influence is the main. But yes, we know that tear fluid is not that much of its own shape. That's why it will take shape of cornea. But the truth is, actually, it forms on the air tear fluid interaction surface. So both rely upon the assumption of a tear fluid thin layer, uniform thickness covering entire surface, and measurement is made. Both assumes that tear film is entirely covered, uniform, very thin. The early estimates the tear film thickness is about it, but 7 micrometer. But more recent studies, yes, it's studies that 40 micrometer. Uniformity is unknown and could potentially affect the topography, particularly measurement techniques. Yes, isn't it? If tear film particular, I'll show you pictures. It affects. So one of the reflection based is keratometry. And keratometry we have discussed a lot in keratometry video. You can know what's there. What it actually does, it reflection from the cornea from approximately central 3 mm zone cornea, and that reflection image is there, which is basically virtual and erect image, and we have to measure that image, and then we convert that measurement to radius of curvature, and we can convert radius of curvature to power, isn't it, diopter, by this formula. And I know where this formula comes. I think you know that we assume that for keratometry we reduce the value of corneal index to this, because we nullify the posterior segments minus 5 diopter. So that's why from anterior segment we gather complete power, by reducing uh, refractive index. Basically, refractive index of cornea is something like that, isn't it? 1.376. So this is the formula from radius to, and this formula will save a lot of time when you are actually doing as an optometrist, like cornea. What do you say that? IOL calculations, and you're sitting there and doing IOL calculations. It will save your time. Okay, eye movements and decentralization or tear deficiency can affect, definitely, isn't it? So keratoscopy or photokeratoscopy as a keratometer only analyzes approximately 6% of the cornea, because keratometry means only a small circle, isn't it? Not inside the cornea, not inside the center, outside the, but a ring, isn't it? That's very small area keratometry can measure. An additional modality and captures entire cornea needed, because entire cornea matters, isn't it? So keratoscope is qualitative reflection-based instrument, measures 70% of total anterior cornea. Okay, so basically limited by optical system machine, and projected light to target. Usually placebo disc is as a target, and simple flashlight. So basically keratoscopy is placebo disc reflection. So placid disc is a series of concentration ring. We know that, don't you? Placid disc is very famous in optometry. Or the cone with the illuminated ring lining the internal surface of the instrument. According to change of the shape of the reflected ring and the space between them. That's very important. First shape, then the space between that 10 and 12 rings, isn't it? That's very important, because it will indicate the radius of curvature. So we can take idea about the shape of the cornea. For instance, a small and narrow closely ring is steeper the region. Exactly, this is line, great important line. Whenever there is a small and narrow gap between two uh, placidotis ring is small and narrow, then it suggests directly there's a radius of curvature is small. That means curvature is high. I have already told you radius of curvature and curvature both are different things. So curvature is high, radius of curvature is small. Okay, this is the example, isn't it? So this is placid ring. So can you, this is shape, isn't it? So it's very, from shape you can say this is the axis, elongated area, and this is axis meridian, and let me use, and this is power meridian, isn't it? From shape you can tell that. It's very important. And see, in this, the lower one, it's very important. The distance between this gap increases, means radius of curvature also increases, flatter, or curvature decreases at the same time. See here, distance between this very packed. Okay, very packed. It means in this position radius of curvature is smaller or curvature higher, isn't it? So it's very important, the distance between these two lines you have to watch like this. Okay, it's very important. So, computerized video keratoscopy is projection-based topography, consists of placido discs or cones, small and larger, which project mirror of concentric light ring, and video camera that captures the reflected light and light from tear film layers, and the software analyze the data. That's video keratoscopy. Evaluation of the distance between concentric rings, dark and light areas, maximize the contrast, is variable number in the point shorter distance, the higher the corneal power, and vice versa. Basically means the distance between two ring, that matters a lot. The smaller the distance, higher the power, isn't it? It's simple. So after analyzing the data, they plot the computer as a color map. It's simple thing. Okay. So Placidix cone may be larger or smaller according to the manufacturer. It doesn't matter. Larger the cone, the more rings and the wider area can estimate. That's very important, isn't it? The Meyer of most system cover cornea over diameter of 11 mm, which is fantastic, and excluding central cornea diameter of, oh, it's very central, isn't it? Very central, excluding only 0.3 mm diameter central cornea, and the prelimbal, so basically limbal area 1 mm also exclude. But Scheimpflug system include data that from very central cornea. But Scheimpflug system, yes, that's why Scheimpflug system is superior, isn't it? Scheimpflug system is very good. Note placido disk systems are more accurate in areas between 3 to 6 mm. They are more accurate. I don't know, but it's like that. So see, this is placido disk. You can see that. Can you see here? Distorted Mayer in video keratoroscopy. Mayer are distorted superiorly due to an old paracentral corneal scar causing irregular astigmatism. This area, can you see? There is distortion. Yeah. And another thing that I want to show you. Can you see this area because of tear? So Mayer definitely not at all in particular position. So can you see? Just pause the video and see. Okay. Okay, so I want to show you the video characteristics. This is 3 mm area, 0.3 mm area that is excluded. And keratometry means only line, isn't it? Keratometry means line, not keratometry. The funny thing, people think that keratometry means the 3 mm area. No, it's not complete 3 mm. It's just a line in that 3 mm zone, approximately. Not outside of it, not inside of it. And that's quite an amazing thing. You must understand that. Keratometry don't give this point, this particular point. It doesn't have to do anything with the keratometry. If there is a scar, it doesn't notice. Okay, so you have to understand this concept. And photokeratoscope, definitely there is a space, but video keratoscope, there is central space is very, very, very less, and the Myers definitely very high, 25 rings. In this case, a little bit, it covers around 70%. It covers a lot, isn't it? But in case of Scheimpflug, this circle is small, 0.3. It also covered by Scheimpflug. So let's discuss a little bit about advantages of keratometry, photokeratoscopy, video keratoscopy. What are the advantages? Routine clinical application? Yes, definitely keratometry is very, very easy. Video keratoscope also. Management of complex corneal cases, don't use this. Okay, definitely video keratoscopy. Research tool, video keratoscopy, it is used. Hard record for audit and litigation purpose, obviously you can. Serial analysis, keratometry, this is good. Good correlation with the visual potential, that's very good. But central 3 mm keratometry can do good analysis. Affordability, oh, I don't know about it. Okay, so limitations of these three, just compare it. Okay, examine air tear interaction, not corneal surface. Yes, yes, yes. Okay, tear film matters because it's projection. No direct measurement of corneal area. Yes, yes. No direct measurement of peripheral cornea. Yes, definitely peripheral cornea. This is the good. Yeah, video keratitis is good. Reduce sensitivity of peripheral cornea. Yes, and very steep and very flat corneas. So basically limitation. Yes, yes, but it doesn't have that limitations. Okay. So irregular corneas, definitely limitations by this. This is good. And I think keratometry, it doesn't work at all. There is a high limitation. Complex corneal changes, yes, definitely it is limited, but video keratoscopy is not limited. Assumption of algorithm may not be valid. I don't think. Yes, they are, because why I am not able to explain you this concept, because I haven't worked with this instrument, especially with computer video keratoscopy, photokeratoscopy. That's why I feel like something little bit difficult to explain things, because I cannot vividly remember these things. I only talk about theoretical aspects. So subject interpretation of the display data. Yes, interpretation is always needed, and that's what you make optometrist and optometrist, isn't it? So let's slide a little bit on slit photography. Slit is basically you project slit on the cornea, and then you record from you project the slit cornea and numbers of slits, and from right and from left to, and then record it from camera. And the concept is actually triangulation concept, but I will explain in later video what is concept of triangulation. So what is basically simple way to understand slit uh, projection based topography? It's multiple complementary beams. It's 14 op scan, 20 for each nasal and temporal, both sides it projects. So each slit contain 240 data. It's very good in case of data. Okay, and given the total over 9,000 data points on each surface. That's, isn't it, that's good, great. Each with a resolution of 2 micrometer. My goodness, resolution! How good resolution slit scanning has, isn't it? The reconstruction algorithm generates the map of the entire anterior and posterior surface. Now here we come. From slit scanning method from OpScan, we come to know about posterior surface. That like it's gold, because posterior surface is very important in case of keratoconus diagnosis, isn't it? So that's why posterior surface is from the slit scanning. Then definitely off scan, definitely Simplon camera. Yes, we'll talk about it later on. An anterior and posterior surface and subtraction of these two maps can provide corneal thickness. So basically corneal thickness in case of topography by elevation map or whatever, it's basically subtraction of the two maps, what like anterior surface and posterior surface. That's why it's a little bit better with OCT, but yeah, it's grossly reliable. So limitation is relatively long time. It will take 0.8 seconds required for individual image 40 slits, and possibility for introduction artifact due to the eye movement. So there is possibility. The number of study has illustrated the inaccuracy at the locating posterior corneal surface underestimate the corneal thickness after refractive surgery. So that's why a little bit studies are shown that, but yes, but posterior surface we have to give credit to slit scanning. After that, Simplon definitely does its work best till now. So for refractive surgery, definitely Simplon, but not slit. But I have seen that instrument early days. For that, I think I was in first year of bioptometry, but maybe. So let it be. So just I think I made the point that this presentation is more about roughly knowing other than Simplon. Okay. So again, these are all things in job sir, and I think refractive surgery. You can see that I'm in love with this book too. Okay, so I think that's all. Bis dann. Cheers.